Okay, morning everyone. Welcome to this Careers Pathway programme. Today we've got William and Chloe from Queen Mary University. It's going to give you some insight into electronic engineering and computer science. All students are muted at the moment, so you need to put any questions in the chat and they will be answered either during or at the end of the session. Okay, over to you, William.
Okay, so my name's William Marsh. Thanks for coming along today, everyone. I'm an academic member of staff at QMUL, and I've put a blurry picture, I don't know why it's blurry, on the front of the slides of the campus at QM, as we remember it. It's a while since any of us have been there much. But I'm not just going to be talking about QM. I'll use my university to provide some examples, but computer science, electronic engineering offered very widely at lots of universities. And I'll talk to you a little bit about some of the choices that you have. So we're going to talk about careers, we're going to talk about the subject and university. Now, one of the first things to say is that there are lots of names they're all much the same, actually. It might be called computing, might be called software engineering, it might be called IT, and then in electronics, electrical engineering, electronic engineering, communication systems engineering, all sorts of names. They're all closely related. Oh, computer systems engineering. So that's another name we use actually for a mixture of electronics and computer science. But other universities will use other names for that kind of thing. So I'm going to talk about what the subjects are. Chloe's going to tell us a little bit about her experiences. We're going to talk a little bit about the huge range of careers, great variety of careers and the different skills that you need. And then maybe end up with a little bit on the courses and the choices you have there. So what are these subjects? Well, where are they? And of course, the answer is they're everywhere, aren't they? The electronics, computer science is pervasive. So the latest cars, but also the most boring things like domestic appliances. And I'm sorry about this very old picture of a iPhone. You might know what model it is. I'm a bit bad at these things. I think that's rather an old one. But a lot of these devices, all of these complicated devices nowadays have computers. Computers have become a kind of universal electronic component. So I thought I'd find a picture that showed some electronics and computer science. These are the robots that are produced by a company called Boston Dynamics, just been bought out by another company from Korea. And spot the electronics. Well, there are lots of digital chips inside these devices, and those were designed by electronic engineers who, of course, put them into circuits. So there are circuits there, and lots of sensors. The robot will have a huge variety of camera sensors and touch sensors and sensing force in the limbs. Then I don't know how these things communicate, but they're probably using wireless or certainly using wired networks through the device, connecting together the different bits, and electronic engineers study that. Lots of very complicated control algorithms. So lots of small computers inside these devices at different points, and electronic engineers do that. Electronic engineers do lots of programming, and they understand about things like motors, lots of motors here you can see, electric motors, and power. Then there's a lot of computer science here as well. The computer scientists do lots of programming, like the electronic engineers, but they're perhaps more interested in the algorithms, the software engineering. How do we take large amounts of code and organize them well? Like the electronic engineers, they study networks, perhaps from a higher level, more to do with the algorithms, less understanding of how the wires actually work. And then these devices will be using lots of artificial intelligence and machine learning. An application of machine learning is in computer vision. They have cameras in, and another application of AI is in planning, deciding what to do. So if you look at this, there's no one person who can make these devices. When you go and work on something like this as part of a job, you bring a particular skill to the team. Maybe your skill is it's not just electronic engineering, is it? In the materials engineering or the fabrication, or maybe you're an embedded programmer or an expert on networks, or maybe you're the AI man or the vision. And because of this huge range of skills, all of these jobs involve a lot of talking to other people, working as a team. Nobody works on their own. You always work as part of a group. And so actually being good at explaining yourself and being good at talking to other people are important parts of these jobs. Well, I found this picture from Queen Mary. We have a robotics research group. Actually, it's half in electronic engineering and computer science and half in another engineering department. And here they're working on human augmentation, so producing perhaps for people who are injured or disabled, or maybe just for people who want to be super strong, the capability to grip or grasp things that they wouldn't be able to. So just digging a little bit into computer science, this was an example one of my colleagues produced. Let's think about all the technologies involved in a web application. And there's lots of coding. So some of you may have done some coding and some of you not. It's by no means essential to do coding before you go to university. Most universities will teach you coding from the ground up. It's a very good idea to know that that's what you're going to do. I say to students, if you're thinking of studying computer science or electronics, you should be ready to learn coding. You should have some idea what it's about. Maybe we'll ask Chloe later where she first did some coding. Our web apps are working over networks, and nowadays most computer programs are not just on a single device but connected. So we need to understand something about how networks work and what is this HTTP protocol and what are these IP addresses. Both electronic engineers and computer scientists study that. Then our web apps often have a database. A few years ago, one of our ex-students came to an open day. He had been a graduate for about 5 years, and he was working for eBay, and he talked about the database he was working with. And I don't think it was megabytes, I don't think it was gigabytes, I think it was terabytes. And those were skills that he'd obviously mastered in the industry, because universities don't know about databases that large, but he'd built on his study of databases in computer science. Now, I'm quite good at databases and I'm quite good at coding, but I'm terrible at user interfaces. It's quite a different skill, how to design an attractive, convenient to use user interface. That's another topic that computer science studies, and we shouldn't think that everyone is equally good at all these different aspects. There's different things. Security, that's a really big problem, and have to understand a lot about how things really work. So how operating systems really work. There have been some big concerns about security issues to do with the details of how the chips work and the possibility of extracting information that you're not supposed to be able to see because of the details of how the processors operate. Too complicated to explain, but sort of thing that electronic engineers look at in a lot of detail. And then performance, again, understanding in detail how the operating system, how the chip works. These are all topics we study in university. So just some summary of the topics that make up these two subjects, and you see they overlap. Everyone's doing programming, everyone's studying computer systems, networks. Electronic engineers perhaps studying the lower level details, how to get the information on the wire. The computer scientists perhaps studying more how to use these fantastic communication devices in interesting applications. Electronics has a little bit more mathematics and physics in it. I'll talk a little bit more about mathematics and computer science in a moment. There's a theory end in computer science, and that's one of the things that distinguishes different courses. Some courses have more theory and mathematics, some rather less. Of course, the electronic engineers build circuits, which the software engineers go, well, that's fantastic. This computer works. Now we worry about how to build really complicated software systems. So to begin with, you write small programs you can work on your own, and then you probably as part of a team learn how it is to create much bigger computer programs, which are too big for any one person to create on their own. And these are the kind of basics, the groundworks, but after that, people go on and study some of the more specialist topics in computer science. And both of these subjects are very practical. They have lots of teamwork. Our students spend a lot of time in the labs. We'll ask, maybe you want to ask Chloe later whether she works hard and whether it takes time. I just put a couple of slides in on some of the specialist applications that you might choose to look at towards the end of a degree. Some of these are computer science, some of them are both computer science and electronics. So this one is how you use lots of very large computers working together to solve big problems. It's the sort of techniques that Google and Facebook and others are using. So you've got a large amount of data, you need to share it out between different computers, get each of them to do a part of the calculation, and then summarize the results. And this is using a framework called MapReduce, where we map the problem onto a lot of separate work streams, and then we have a way of pulling the results together at the end. So for example, if we want to search a lot of web pages, then we can do that on separate computers, and then we take the search results, maybe we want to order them, we need to bring them together at the end. And Hadoop is a code framework that enables people to do this. And this builds on knowledge of programming and algorithms and systems and networks. This is actually a course I teach, which is now, rather than looking at very large computers, looking at really small ones, and ones that are very cheap. You'll find these sort of computers, these very small ones, in every kind of device. Lots of them in cars, controlling the airbag or the engine or the wheels or the braking and so on. And we learn how to program very small computers, perhaps with no operating system, and how to get them to do several things at once. Oh, great. So now we've got to Chloe, who's going to grab control of the screen. And Chloe's a final year student on our computer science program, and is going to talk a little bit about her experiences.
Just check, can you hear me and can you see my screen?
I can, yes.
Perfect, thank you. So hi guys, as William just said, I am Chloe and I'm a student at Queen Mary studying computer science, and I'm actually in my final year, so I haven't actually got long left, which is both exciting and very scary. Just wanted to talk to you a bit about why I wanted to do computer science, or more my pathway to it really. So it's kind of the cliche thing of it's always been an interest of mine, which it has really. I really enjoyed it in school, or I say computer science. When I went to school, computer science wasn't really a thing in GCSE, it was IT, which of course are slightly different, but same basis, I suppose. Yeah, I've always enjoyed it. It's always been an interest of mine. I've just intrigued by it already, but I never quite knew sort of how to get there. So I ended up sort of exploring different career routes and things like that. And well, ultimately they didn't really work out because I knew they weren't for me and I wasn't happy doing them. So I decided to take my BTEC extended diploma in IT, doing the software development route, which is actually where I did my first bit of proper coding in C+ and VB, if I remember rightly. Yeah, and then it was in college where university became the goal, and my college tutor almost bullied me, I suppose, into saying that I'm going to go to university because he showed that belief in me. And coming from sort of someone from, I suppose, an underprivileged background, I never thought that I could get there. But yeah, I ended up sort of applying, and then I finished with a triple distinction star, which is about A star equivalent to A level. And yeah, I got into Queen Mary 3 years ago, which I was amazed about because I honestly didn't think I'd be able to do it. But yeah, and the thing about computer science is it's the opportunities it gives you, specifically for women as well. I feel like in the education system in terms of schools and stuff, women in like the tech industry, it's not really a known thing. It seems to be quite a masculine industry, but I now believe that actually the industry is a lot more welcoming to women, and it's all the doors that it can open. I mean, computer science isn't just sitting at your laptop all day coding. It's a lot more than that. And it can be so much fun. And also the evolution of tech. So as William said earlier about that old iPhone on the screen, obviously we now know that things have evolved, things have changed, and it's constantly changing all the time. And I think computer science really is the future. So just to go on about my studies, the thing I most enjoy about computer science is the creativity of it. So like I said, I mentioned that I do computer science to someone the other day, and then they went, "Oh, you code all day?" And I was like, "No, I don't actually, because computer science is everything from the research behind a product to designing it to actually creating it." And in my 3 years, we've actually created a lot of apps and like web apps, software apps and things like that. So just on the slide there, you can see a design that my group made last year in a GUI module. It was a web app, clearly. And yeah, but we do loads of things. We do like portfolios. We have a whole module on software engineering where we created a new fitness app. We're constantly creating things, and it isn't sort of boring or anything like that. It's so much fun. Like just in the other pictures there, we have the checkerboard picture, which is something I did in computer graphics. We just messed around with the cow there, who's called Spot. If you didn't know that, apparently it's a computer graphics term. But yeah, we messed around with that a bit. You can see like reflections, and it doesn't sound great, but when you're doing it and when you're actually seeing it, it's well worth the struggle and the work you put in. And then just below we have Suzanne there, the monkey. Obviously it doesn't really look like a monkey other than the shape. We've just got loads of colours and rainbows and reflections, and I put them on the slides just to show that computer science is so much more, and you can have fun with it, and it yeah, it's fun basically. And I'm also currently doing my final year project, which is a research and prototype project based on blended learning within universities, and I'm creating a sort of all-in-one web app to solve the problems that we're currently facing. So I'm having so much fun doing that. It's nice to do something relevant as well, and it's current too, and very quite close to all of us at the moment. The challenges in my studies are the fact that we learn so many programming languages and use so many different bits of software. I mean, off the top of my head, the programming languages we've learned are obviously you've got Java, Python, then you've got HTML, CSS, JavaScript, PHP, MySQL, NoSQL, XML, Django, React, Preact. There's just so many different things that we've used and we've learned. We've used networking software to check what's going on in the background of your web searches and stuff like that. And it's really intriguing. The challenge is obviously differentiating everything, because at some point you are going to be coding in Python and you're going to put something that's meant to be in Java, and it's going to get really confusing, but it's well worth the like I say, it's well worth the challenge, and it's really rewarding in the end, especially when you've got that bit of code that's not working, and then you spend ages trying to figure out why, and then you realise that it's because you've missed a semicolon. It's those times that really put it all into perspective, and when that code's finally working and your app is running perfectly, you can just sit back and you just smile and just laugh it off. It's crazy sometimes. Just within Queen Mary, I also do some peer-led study support schemes. So I'm a buddy scheme mentor. So I mentor a group of 11 first years, helping them settle into uni life. This year, more important, especially because they've not really had that chance to make friends and build those support systems that you really need in university. And I'm also a past mentor. So peer-assisted study support. We run weekly drop-in events for educational and even personal support, whatever anyone needs really, from foundation year all the way up to masters. They can just come into the past session and we'll just have a chat. And 9 times out of 10, they'll leave feeling so much better about their studies and everything like that, because it can get a lot. It can be really intense. But like I say, it is all worth it in the end, because even me now, in my 3rd year, thinking back to all the stress, all the work we had to do and everything you go through, I'm looking back and I'm thinking, I'm about to graduate and I've learned so much. And it's not until now that you realise just how much you have really learned, and it's valuable experience for when you go on. But also, most importantly about my studies was the people. And I'm sure this isn't just specific to Queen Mary. This is like every university. It's the people. Like, university is so much different to school or anything like that, because you meet people for themselves. You meet a wide range of people. The most important thing is everyone's willing to help. You can make a friend for life just by asking for help. So I made a friend because she asked to borrow a pen on the first day. So the people you meet at university are probably going to end up being your friends for life. And going on to the future, talking about that, so like I say, I will be graduating this year. I'm in the class of 2021. Unfortunately, due to COVID, we don't get a ceremony, but there'll be a virtual event, so that's fine. So through Queen Mary, I attended a Get Into Teaching webinar, and I ended up applying to teach. And I can happily say that I have secured a placement starting in September with Havering Teach Training Partnership. I'm studying a PGCE with QTS in secondary computing. So I've thrown myself right in the deep end there, but I'm really excited because teaching is something I've always wanted to do. Again, never really knew how to get there. So I've just took one step at a time, and Yeah, I'm really excited to graduate and get started, to be honest. And I did a little research just for this event, really, just to give you an idea of what current students are doing, like aiming for now. So I asked a few people that I know doing my course what they intend on doing with their degree. And I've just jotted down a few answers here, so forgive me for reading off a paper. So some of the jobs people are looking for are software developer, data analyst, marketing consultant, financial analytics, data science, machine learning, data mining, web development, security, AI, game development. And then there's also someone I know doing creative computing. And she recently had a talk with Instagram about design opportunities and design roles within their company. So, and I know other people that have done internships for big companies and things like that. But the reason I did this is just to show what current students are looking at now and just the doors that computer science can open for you. Like, it's not just one specific thing. Like, it branches off so many different job roles and so many opportunities for you. So I thought that would be useful for you to sort of hear what students are looking at right now. So I think that may be me done. I'll hand you back over to William.
That's great. Very, very much. And
no worries.
We've got a bit of an echo, so if you turn your microphone off. But can I encourage everyone, if you've got questions for Chloe or for me, do start thinking about what the questions are, put them in the chat. We're looking forward to answering your questions in a minute. Because Chloe was criticizing my iPhone pictures, I thought I'd find a really old phone. And here I'm sitting at home, so I managed to find this on the shelf. And it's probably 20 years old. Jan, do you remember somebody older than you having one of these? And of course,
be anybody.
So, of course, the challenge is that when you're at university, you're studying for a long career, and we know that technology is going to change a lot over that time, don't we? I think the first computer science degrees from Queen Mary were in about 1969, and the people who studied then were about halfway through their career when these arrived, or perhaps two-thirds of their way. They're probably mostly retired now, but tremendous changes in technology over that time. So thanks to Chloe for introducing careers, and I want to talk about that a little bit. And the main point is terrific opportunities, but enormous variety. Enormous variety. And as you think about what you might do in future, you've got to find the job that's right for you, suits your particular skills. This is one of these pictures that industry organizations like to produce and tell you a huge amount of turnover. They're talking about the digital tech economy. So that sort of includes IT and electronics. And London's a really big place, lots of digital jobs, and the salaries are really good. That's not a starting salary, that's better than a starting salary. Maybe it's a starting salary at the bank, so they pay lots. So huge opportunities for jobs in tech, huge variety. What are our companies? Well, firstly, the range of different jobs. So this is from a report that was produced recently, which was really saying how confusing it is for people going into jobs to understand all these different job titles. And they identified a number of different job areas. I've simplified it slightly. Work in cyber and information security and data, databases, networks, digital business, software development. And then here's just a selection of the job titles roughly against the right group. So you can be starting at the bottom, a user interface designer or a tester or a programmer, or you work on brand development or product design, or you could be a telecoms engineer, or you could manage a database like the ex-student who was working at eBay, or you could be a security analyst. So lots of different jobs. And then industry talks about skills. So this is a very important point. They're not looking for qualifications, they're looking for skills. And there's a huge variety of skills. Nobody has all of these skills. You pick a job that matches the skills that you have and the interest. Now, what do I mean by skills? Well, there are the specific technical skills I've listed in the purple column. Knowledge about how systems or networks work, being able to do data analysis, being good at programming, understanding electronics, and so on. These are skills. But all of the companies also talk about the other soft skills, they call them. I don't know why they're called soft skills, because they're no less important. The ability to work as part of a team, being able to communicate, being creative and doing design, being analytical, being good at logic. You might think that those last two don't go together, but well, they can actually. Programming is quite creative as well. So this was from an industry report a while ago. These things keep coming out. Firms report a strong demand for technology staff, lots of vacancies. And then they talk about the skill gaps. What are the skills that they wish their recruits had? Or from your point of view, what are the skills that will push you to the front of the queue? And interestingly, what they've listed here are not the technical skills. They seem to take those for granted. They're the other skills, the business acumen, practical experience, leadership, management. So how are you going to get those skills? And here are some hints. So it's really important to realize that when you're at university, you're not just acquiring the technical skills, you're getting involved with other things and learning these business acumen, practical experience, leadership. How do you do leadership at university? Well, not in the lecture room, but more in football or music or drama, the other activities that you might do at university. I'm going to say a little bit about apprenticeships. It's another opportunity to work and study at the same time, and then various other opportunities to work and study. We have some degrees with tech partnerships, so they help introduce the world of work while you're studying, and we have internships as well, and we have year abroad, and many other universities will have these similar kinds of programs that help you to get ahead with the work skills and make university fun. So not just the technical and academic skills that people like me are interested in, but the broader set of skills that matters so much to employers. So year in industry, we call it, it's sometimes called a gap year. A lot of universities have these, we have them. You have to get a job, we help you do that. Do have a look at QM webpage. There's a nice video you might find a link to that some of our students made. So you study for 2 years at the university, we help you work to get a job, and the jobs are paid. You work for a year with a company. The salary is reasonable. There's a small reduced fee from the university, but you end up quids in. It doesn't cost more, it costs less because you're working. And obviously this is very good for your CV. It helps you get a job, but perhaps more importantly, it helps you to understand what kind of job role is important for you. Our students often talk about how surprised they are at the variety of jobs. I remember one student who had done a job with a network firm, Cisco, I think, and he'd been doing programming, and he came back from his gap year and he said, well, I'm quite good at programming, but do you know, that's not what I want to do. Not enough communication, not enough contact with people. He applied for jobs in sales. That's what he'd learned from his year in industry. He'd learned more about how the industry worked and where his particular skills work. He discovered that for himself. Oh, these are some pictures they produced a while ago. a sort of montage of the different workplaces that they were at. And of course, it's scary getting into a workplace for the first time, and a year in industry is a way of, when you leave university, having more experience. You can also do summer projects as well. They can be a little harder to get because companies actually like to take people for slightly longer. Great, so now we're going to do Mentee, and if I start the thing displaying, I'll have to just change what I'm sharing with you. So I'm hoping somebody's going to confirm that they can actually see this. Type something in the chat. And okay, so I've thought of some things you might think about. That's great. Thank you very much. That you might like in a job. And so if you go to mentee.com and type in this number 26474699, then you can rank these things. It's anonymous, nobody sees your preferences. Is it the starting salary that'll attract you? Do you worry about my mobile phone effect, the long-term security? Will you still have a job after 20 years? Do you want the work to be interesting? Are you mainly concerned that the work is socially useful? Do you want to avoid very long working hours? Do you want to have good holidays and not long working hours? Or are you mainly concerned with the longer term salary prospects? Even if the starting salary is not so great, would you focus on a job that has good longer term earning? I have no idea what your preferences are going to be. So it'd be great if everyone can have a go at answering this. We've got one answer so far. Two. As an academic, I think my priority must have been interesting work. It's a great privilege to be learning new things, discovering things. The working hours are not short. The salary prospects are not so great. Security is pretty good, I think, but long working hours. Should we have a look at what you come up? Continue to answer them. Okay, so great mix of different views there. Interesting work. I think that there are lots of interesting jobs in the digital world, and people's interests differ. So it's a really important point, but there are lots of interesting work. So go on to my second question. Maybe, if I can get it to work. Oh yeah. So now you're free to type in whatever you would like. What factors are most important to you in choosing a university? So you might be thinking of things like the location or the details of the course or where your friends are going to go or the sports facilities or the social life or whether it's in London or whether it's out of London or lots of different, or the reputation of the university or lots of different factors that maybe could play a role in this. As you're beginning to think about this, I guess after the summer, you'll be filling in UCAS forms if you're planning to go on to university. Okay, some great thoughts coming. Thank you for everyone who's contributing to that. Okay, location's important. I think just like jobs, there's no one best university. You're finding the one that's best for you. And locations emerging as the biggest. Teaching quality, that's interesting. At university, we're researchers. We try and teach reasonably well. Maybe you want to ask Chloe that, how good we are at it. But more than anything else, a university is a place where people study the subject, so you have the opportunity to learn from their knowledge of it. Reputation, accessibility, social life. I have said those other things we do at university are very important. So I'll just finish up with a few slides about university study, and then we'll be ready for your questions. Okay, so there are lots of course titles that we have, and the kind of key point is don't take too much notice of the titles. They're university marketing. Right screen. Okay, so these are the programs we have at Queen Mary. You'll see other mixes of programs at different university, but these kind of give you some idea. We have some computer science programs. Quite common to have some joint programs. We have one with mathematics, other universities sometimes with language. We also have a joint program with business, and that's supported by Tech Partnership. I'm going to tell you a little bit about that. Chloe mentioned a friend who studied creative computing, so that's a sort of design engineering meets computer science. We have some programs in electronic engineering, including one in computer systems engineering, which is a kind of mix between computer science and electronics, digital electronics and software engineering. And actually in another school, we have a program in robotic engineering as well, which is a mix of engineering and electronics and computer science. So Tech Partnership is an organization which brands a number of degrees. You'll see a number of universities teach the ITMB. The Tech Partnership doesn't teach the program. They don't fix exactly what's in it. What they do is they provide a link to companies while you're studying. It doesn't cost anything. It doesn't add to your studies. They're just events that you can go learn about industry, and there are often competitions. Our students do very well in these competitions. So we have two Tech Partnership degrees, ITMB, which is Computer Science and Management, and Software Development for Business, which is really just computer science with the Tech Partnership activities. And I'm pretty certain UCL does a ITMB, as do a number of other universities. So if you Google ITMB, you'll find all the universities that do that. Then creative computing. It's a fusion of art and science, the sort of thing I don't understand, but for applicants for this, we look for some evidence of creativity, some work with design or art, and a number of courses in this area are emerging. Creative computing, they're sometimes called, it's the name that seems to stick most. In London, I know Goldsmiths offer one as well. So you'll see a variety of these courses working at the intersection between creativity and computer science particularly. So this is a slide about apprenticeships. So this is a new opportunity that exists to, these are jobs, so you work and study at the same time. So this is a quite different route. It takes 4 years because you're working and studying. One of the attractions is that the tuition costs are met by the employer, so you don't have any debts. The programs vary. In ours, you spend 2 days a week on campus during term times, and you study some university modules, and you do some work-based projects as well. And you can find out more about these on the QM webpage. If you just search for degree apprenticeship at QM, or the government webpage, which is called Find an Apprentice, or UCAS have got a webpage as well, which actually links to the government page. So just search, it's called a degree apprenticeship. So if you search for that, happy to talk more about that if anyone's interested. The QM page sets out some of the pros and cons. You get a job, but you're stuck with the job for 4 years. You expected to work and study. It's hard work. You don't have any debts. That's good. You don't have any fun. That's not so good. So there are some trade-offs. So how do degree courses differ? Well, one difference is the mathematical prerequisites and the amount of mathematics. So electronics requires typically a maths A-level. And CS courses vary. If you go to UCL, they will require lots of maths, and their course will have more theory in. Other courses will be more practically oriented. QM's course has a theory component, but doesn't actually require you to have a maths A-level, though it's useful if you do. And then there are lots of options. You can have a foundation year, a year abroad, a year in industry, joint programs. These are all options to explore. And I mentioned, for example, that we don't have joint programs with language, which some universities will do. Programming is taught everywhere. All university computer science and electronic courses have programming. And it's a really great skill. You can earn money from programming, but it's not the only skill. There are lots of other skills in system management or database design or user interface development or marketing or requirements analysis or business analyst. It's not programming's not the only skill that matters. And it's not essential to have studied computer science or even done some programming at sixth form. It's a very good idea, like Chloe did, to have done some programming before you go to university, because you know that that's the nature of part of what you're going to study. But the amount of programming our students have done varies a lot. Oh yes, some universities have very specialist titles. Typically these titles vary more than the contents of the course. So if you're going to be a games developer or an artificial intelligence specialist, you still have to learn the basics of programming and databases and logic and so on before you move on to studying the specialist topics. This is a couple of graphs for men and women showing the return, subject return 5 years after graduation, the variation. And we can see, I don't know if you can see my cursor, but computing's sort of up there. It goes engineering, goes law is lower, engineering is lower, architecture is lower, computing, then maths, nursing, business. So these are graphs that take account of your school qualifications. Okay, so given your school qualifications, what's the return relative to the average degree for somebody with the same school qualifications? This is the same chart for men. Yeah. Why did I have computing in red on the previous one? Don't know. Yeah, computing's a little bit higher up on this one. They're bars because obviously there's a variation from one to another. The shape of the bar is our uncertainty about where the average earnings are. So it's better to go into medicine or economics, but if you're not studying those subjects, for everyone, computer science offers good returns. So I hope you've got some questions ready, and we can unmute perhaps. And the questions are not just for me, but for Chloe, or primarily for Chloe. The world is digital, lots of opportunities working in technology. There are practical activities. You learn programming. There's a theory element to it. Practically, our students are busy. I think some of the time they enjoy what they're doing. Great careers. Problem solving is probably the one word that applies to the great variety of different careers. And your job is to work out which careers are going to be interesting for you, and then to gain the skills that you need little by little, perhaps with an apprenticeship, perhaps with a year in industry or some work experience, getting the skills, but not neglecting all the other things you can do at university. Great. I'm hoping for some questions. Jan, you're muted at the moment.
Okay, thanks, William. Would you like me to unmute students so that they can put their hand up if they want to, rather than put questions in the chat?
Yes, we're not such a large group that.
Yeah, we've got 21,
Yeah,
which is a really good turnout. So
you can talk or type as you prefer.
okay, students, now that you are able to unmute yourself, but if you put your hand up, Chloe or William will take your questions for you. Come on, who's going to be brave? There you go.
So go ahead, yes.
Carmen?
Most of the engineering degrees require maths, but I don't have a maths A-level, but I do electronics. Would I still be able to get in?
Well, so that question can be general, or it can be about Queen Mary. So you're interested in studying electronics or computer science?
Electronics.
Okay, so actually we do require a maths A-level for our electronics course, but you might find other places that don't. The other option you have, of course, is to do a foundation year. So if you know that that's the route where you want to go, the foundation year has quite a lot of maths on it, actually. So it's quite a hard course, but a really good starting point. You can then go on to, if you do the foundation at Queen Mary, you can go on to Queen Mary, or you can go on to other universities as well.
That answered your question, Tommy. Yeah. Okay, anybody else for a question? If you don't want to unmute yourself, then you can put your questions in the chat. I think the presentation probably covered most things, William. It was brilliant. But come on, students.
David wrote a question in the chat. Is work experience a good way to gain skills before uni? From a student's point of view, it's not really necessary, I don't think, because the first year of uni is all about getting you up to that standard to get you through the rest of it. So the first year is covering all bases, and then after that, that's basically where you gain the experience you need. So if you want to, I guess you can, but I don't think it's necessary unless William wants to add to that.
Well, I would give a slightly different answer. You see, I think that the whole business of getting a job is a ladder, and you climb the ladder. So your first work experience before university may be not necessarily the most exciting work experience, but it's the work experience on your CV that helps you then after your first year at uni that you want to apply for a more interesting job. And so you climb the ladder. And I don't like to talk about this ladder just in terms of your CV, because also every time you go out and do some work experience or some other activity, you find out more about yourself. You find, what are the things I enjoyed about the work experience? Was it solving the problems or talking to the people or being creative? So yes, I think it's a really good idea. Chloe's absolutely right. It's not essential by any means. And other things you might be doing, you might be very keen at sport, for example. Well, that's really good too. And then what are the best things to put on a personal statement for computer science? So personal statements are really, I used to do admissions at Queen Mary, and the thing is that you can never be sure about what anyone is doing with your personal statement. So I always think of it like this. If we look at your application, there's things we can see from the formal bits of it, and then there's other information that we wouldn't know except if you put it in your personal statement. So tell us in your personal statement about the things that we wouldn't know elsewhere on your application. The personal statement's a great rite of passage. It's a great challenge, isn't it? My kids have done it. They're through that stage now. A lot of anxiety. It's important because it helps you to think about what you're doing, what you're applying for. Probably doesn't make that much difference in many of the applications, actually. What did you write in your personal statement, Chloe? Can you remember?
Oh, it was 3 years ago. I think I essentially just sort of, it's not really selling yourself, but you, like you just said, really, you talk about the things that aren't in your application. So it's a good chance for you to talk about yourself. It wasn't necessarily completely focused on computer science either. You do talk about the type of person you are, what you like doing and things like that. If you can tie them into the subject and stuff like that, then that's great. But it's essentially that it's your personal statement. So it's everything, it's you in those few lines. So yeah, something along those lines.
Time to answer Khalid's question before we run out of time. So Khalid, typically you can apply for a course with a year in industry or a year abroad on your UCAS form. Many universities will also offer you the chance to switch over to one of those pathways after you're at the university. So for a year in industry, it's exactly the same study, except the whole course takes 4 years rather than 3 years. You do 2 years of study, then you do the year in industry, and then you come back for the final year of study, often with a job offer already in your pocket from the employer. Okay. Now, at least the way we run it, we don't allocate you a job. You have to win a job. So even if you're on a year in industry, you're not guaranteed to get a placement. What we find is, providing students do the work, they do get placements, but they have to write the CV, do the interviews in order to get it. So look in details at how different universities organise these kind of courses. Are we out of time?
I'm afraid we are, because we've got a full programme today, so they're rolling every hour. So some of the students here and myself have got to nip into the next meeting.
I saw we were up against medicine. I was very upset about that, but thank you everyone for their interest. And,
okay, so Chloe, well done for securing your placement. Sounds very interesting.
Thank you.
And thank you both for giving up your time today. It's been really informative. Thank you.
Bye, everyone.
Bye. Students, make use of the rest of the day. Thank you. Bye. Janet's dropped into